Hi, welcome to Think Human. I'm Chris, and in this video I want to talk about this idea of special relativity, of causality, of time and events in space and time being different for different observers. So how is it possible that one observer sees something happen earlier, another observer hears something happen later? So how is this discrepancy possible? And we can illustrate this by a couple of space-time diagrams. Okay, so here we have a basic space-time diagram. On a horizontal axis we have space, and on the vertical axis we have time. And in here we have two observers. We have A1 and A2, and they are not moving in space, they're only moving forwards in time. And we can look at what happens if A1 tries to send a message to A2. So in here we see that A1 from time 0 sends a message to A2, and A2 sends a message back to A1. So in here is the question of how can we say that anything is simultaneous, that how can A1 and A2 agree that something happens at the same time. So there's a simple way to actually do this. All that A1 has to do is take the time that it takes to from the moment that A1 sent the message to the moment that A2 sent the message back. So the total time here, A1 just has to take it in half and just say that, let's say if A2 said that this time is like 1 o'clock, then A1 can also say that, okay, A1 can set his or her watch that this would be 1 o'clock as well, and then they're synchronized, like, okay, they can agree on all times in the future by doing this. And there is no real problem with this, and everything makes quite good sense. So we could have a look at how observers could disagree. We could have A1 and A2 here, and we could make another space-time diagram for observers that are actually moving in space. So in here we have two observers that are actually moving relative to the A-team, or whatever we want to call them. So we have P1 here and P2 here, and they're moving exactly at the same rate. And this, because it's moving, they're moving quite fast, because speed of light is 45-degree angles. We could see they're moving quite fast, but they're moving at a constant speed. And this diagram is from the point of view of A looking at them. So in here what happens is that B1 sends a message to B2, and B2 replies with a message back. So we could see what happens here. So the usual way we did it is we cut the time into half, and then the half point moment was the moment that everyone agreed on was a certain time, and there from onwards they could have their clock synchronized. So but in here we see one thing. Let's say we cut it in half and we have 2 points here. I didn't make it nearly as extreme to be well seen, but I'll try to point it out by exaggerating a little bit. So these two lines that go through here, these are different times. So from observers from the A looking at this system B, so in this point of view, B1's right now is a little bit earlier than B2's right now, when in fact B1 and B2 both agree that this is simultaneous, this diagonal line going here. But from the point of view of A, one happens before the other. I hope that makes some kind of sense. Now we can visualize another diagram that makes it bit maybe clearer to understand, hopefully. Okay, so we have another diagram, space-time diagram, and in here we have 3 distinct points, and we can maybe name them. We can name them A, B, and C. So we have 3 points, which is A, B, and C. And we could look at observers. How would they experience time? I think I need another writing thing to make it a bit simpler. Otherwise it's just kind of messy. So okay, so for a normal observer, let's say the observer A, for they're standing still and only time is moving forward, and it's normally, and in their point of view the sequence of events is A happens first, then B happens, and then C happens. Okay, fair enough, this is perfectly normal how we experience events in the universe. But if we have the observers B, for example, who experience time slightly differently, then what happens is something different. For A it was 1, 2, 3 ABC, but for the second observer, for the B observers, what happens first, because their whole line of reference moving in space is different, for them the first event is actually B. the second event is A, and the third event, they all agree, is C. That's just kind of a coincidence of the events happening in this way. But in here we can clearly see how we could visualize and how it makes some kind of sense, how we could at least imagine that different observers can agree on different types of things. As we looked at before, depending how fast you are moving, your whole kind of space-time diagram changes its shape and the position where everything is in. So in here, first observer, time is moving normally, they're not moving at all, so it's A, B, C. But for the second B observer who's moving really fast, it can be B, A, C. So kind of a big difference in the set of events and how they interpret what happens actually first. And the weird thing about special relativity and general relativity is that both of these reference frames are equally correct. It's for no one to say that my point of view is correct or another point of view is correct. For all of them, it's actually correct. ABC is correct and BAC is correct. They're equally as correct. So that is the kind of weird thing to wrap one's head around. So this is just a few sort of examples in space-time diagrams how we could visualize how causality and sequence events can kind of get mixed up. I hope it made some kind of sense. I'm not a perfect diagram drawer or anything, but I hope it was at least interesting in some way. So if you have any ideas, please leave them in the comments. Thank you so much for watching and take care.